Hello everyone and welcome. This is a short demonstration tutorial using Cisco CML free tier in which we'll configure routing and redistribution using OSPF and BGP in a two-site campus example. This is not a guide on building a resilient network. The free tier version of CML only allows 5 devices. I might create a larger version in EVNG later if required. As you can see, we have our lab nearly completed. For those new to CML, I will add the last device and its connectivity so you can see how that's done. Here on the left we have the addressing that we will use. So let's add that final switch, name it and connect it. Add nodes, layer 2 switch, move it into place. Rename it. Tick. Right click your router, add link to the switch, create link, and we'll add a text box for the loopback interface that we'll use. 3.1.1.2. Good. Let's start the lab. Okay, good. There's our lab all up. Let's start configuring the devices. We'll start with switch 1. Let's give it a host name. Create the VLANs. Under their respective SVIs. No shot. VLAN 20. No shot. VLAN 30. And VLAN 800. We need to make E00 a trunk interface up to R1. Set the encapsulation .1Q. Make it a trunk. Let's go to switch 2. And do the same. Give it a host name. Create the VLANs. Their respective SVIs. No shot. VLAN 120. VLAN 130. And the transfer VLAN 800. Again, we need to make E00 a .1Q trunk. That's good. That should have brought up all the SVIs, which it has. Shows everything up. And in switch 2, any second now. Can take a moment. There you go. Okay, good. So let's start configuring the routers. So let's go to R1. Give it a host name. Okay, so interface E01 has to be a .1Q sub-interface. 01.800. Set the encapsulation .1Q and the VLAN we expect. Set the address. No shut. We also need to no shut the parent interface. So we should be able to ping the switch from there now. And we can. Excellent. Let's do the same to R2. Give it a host name. Interface E01.800. Encapsulation .1Q 800. IP address. No shut. And no shut to the parent interface. Again, we should be able to ping the switch. Site B. And we can. Excellent. Good. Okay, so next we'll need to configure OSPF so that the switch advertises its routes to its respective router. So let's start with switch 1. Router OSPF 110. Network. We'll do them individually here. And we'll do it a shorter method on the next switch. Not forgetting these are wildcard masks here. Okay, so we don't want OSPF hello messages on the client SVIs, so we make them passive. We still advertise the subnet though. good. Let's go to the router. Router OSPF. Here we only need to advertise the transfer network. Then we see the name should come up. Show IP route. There's our 3 subnets learned from the switch with our O prefix. Or we could say show IP route OSPF, and we'll only get the OSPF routes. So let's do the same on switch 2. We can use the same process ID because it's only locally significant. And we'll summarize these this time. 168.0.0. And we'll be specific on this one. 14. Again with the passive interfaces. 120 and 130. Let's go to R2. Again, only the transfer network we need to advertise. Sorry, enable OSPF one, I should say. And we don't have any routes. Why do we not have any routes? Oh, there we go. Just took a bit of time. Show IP route OSPF. There we go. So both R1 and R2 have learnt the networks that are attached to each switch. Good. Next we'll go to the core. So let's open the console to the core. Give it a host name. And we can see here that we have no routes whatsoever. So first of all, let's configure our interface addresses. No shut. And down towards R2. And from our R1 to the core interface. Same on R2. Let's prove connectivity to each site router. Good. Site B. Good. So let's create the BGP session. We'll use AS number 6501. Need to specify our neighbor as opposed to OSPF because it's not a broadcast. 6501 because we're using iBGP. And we'll do the respective configuration on R1. Tell it where its neighbor is and what its AS is. And here we also want to redistribute what we've learned from OSPF. And we see that neighbor come up already. So let's go to the core. Let's do a show IP BGP summary first of all. There's our neighbor. Let's have a look at the routes. There's our 3 BGP routes. And we can do the same as OSPF. We can do show IP route BGP to only see our BGP routes. Okay, let's do the same for site B. So for the core, we just add another neighbor. And a remote AS. Go to router 2. Tell it where its neighbor is. And its AS. And we want to redistribute OSPF from process 110. And we see the neighborship come up. Let's have a look at the core. Let's do the summary again. There we see 2 neighbors. Let's have a look at our BGP routes. Not quite there yet. There we are. There's the other routes. They just took a bit of time. So there's no config change there. Good. So our core router can see all the networks from switch 1 and it can see all the networks from switch 2. But in this, so far, we still can't ping from site A to site B. And I'm pretty sure you know why. But we'll show it anyhow. We do a show IP route here. We have no gateway. So we'll get our core to advertise a default route. So first of all, we need to have one. But we haven't got any firewalls or internet cloud here, so we'll just create it to null, which is fine. Go into the BGP config. We need to say we want to advertise a default route, and we want to redistribute. Wrong one. Default information originate. let's go to R1. There we are. There's our BGP default route. We'll see the same on R2. Default route. Switch 1. No default route still. That's because our routing protocol between R1 and switch 1 is OSPF. So we need to add that into OSPF also. Default information originate always. We need the always command here because we don't actually have a default route, we've learnt it. We don't have our own. Let's go to switch 1. There we are. We have a default route learnt via OSPF, type 2. Let's do the same on R2. Default information originate always. Let's have a look at switch 2. We have a default route. So, let's try again. Ping to switch 1. It works. Switch 1 to switch 2. Site A to site B. It works. There you go. Full reachability between sites. So, I do hope you found this useful. If so, please like and subscribe and comment on what else you would like to see, and I'll give it a go.